Now it's Miguel Pardo's turn.
Okay. Thank you, everyone. Welcome, everybody. Today, I will explain you a little bit what it consists the SmartNet project. But before of explaining you what the SmartNet project is, I want to give you a brief introduction of what we think are the new functionalities of the DSO, the future of the DSO. From a fit and forget approach to the active distribution system management approach. We're changing, the DSO is changing a lot. Now we are basing our pillars in 4 different ones. The first pillar is the DER integration, the distributed energy resource integration. So this means that the DSO needs to advance and control and manage all that this distribution and the generation distribution that is connected in our network. This is really important for us. The second pillar to increase the new functionalities of the DSO is to increase the interaction between the DSOs and the TSOs. And we have a specific project that later on my colleague Daniel will explain you about, which is the grid codes. The third pillar is the DER forecasting. We need to reduce the uncertainty of energy injections and the improvement of scheduling through an accurate prediction of the DDR production and loads, both things, generation and loads. And the fourth pillar of the new functionalities of the DSOs is storage. It is really important for us, the storage systems, the capacity systems. The use of these storage systems in the distribution network can easily support network operations, so we need to use them. So let me give you a little bit, present you what are the biggest trends that we are facing right now in Europe. One of the biggest trends is the decentralized of the energy. We're turning from a centralized energy to a more decentralized energy. Many countries of Europe are living and experiences this situation. We're shifting from conventional power plants to more renewable power plants. We can't deny this fact. And we are having more flexible tariffs than before, because now we have deployed this smart meter, a piece of technology that we have been deploying in Endesa the last years that will be able for us, to all the customers, to have these flexible tariffs. But at the same time, we can face some obstacles. We can face, for example, if we have a lot of injection of this decentralized distribution energy without any control, we can face grid instability, we can face grid congestion, and we can have volatile markets. So we need to solve these issues. And how we can solve these issues? By 2 solutions. First of all, smart grids. Which is the smart grids? At the end of the day, smart grids, it's about digitalization of the electric network. It's about implementing IoT technologies. It's about having a more sustainable integration of the energies and the distributed energies in our network. And second, we need to have intelligent markets. We need to have more flexible markets that we don't have at this moment in Spain, but for instance, we have in UK, in United Kingdom, or even in Denmark. So what's the key of all these solutions? The key of this is flexibility. We need to work a lot on flexibility. And this is flexibility. Not actually this guy, he doesn't look really flexible, but he doesn't know maybe, but he's using flexibility. Actually, he's making a phone call. He's using the network system operator of a telecom provider. He's using the Vodafone base stations that we have here in Barcelona. For instance, we're using this flexibility. Vodafone has around 400 base stations just here in Barcelona. Every base station has around 5 to 15 kilowatts of power contract. This is how it looks at base station. All these antennas are really nice, okay? But what it is really interesting for us is what is inside. It is this battery management system that all these base stations have. It's about this storage capacity that I was telling you before. It's about management system of the batteries that they have for backup issues. If the grid instability or there is a disruption event in the grid, Vodafone uses this type of batteries in order to provide service to their customers. Fortunately, we have a really reliable network in Barcelona, and they don't need to use this type of batteries. But why can we use of these batteries? Why can the DSO not use these batteries? This can really be profitable for us to do congestion management, to do voltage regulation, and reactive power. It is really interesting for us to use this type of capacity. And this is how it looks, a base station inside. we have the smart meter, we have the antennas, and we have some loads inside. We have the lighting, the DC power systems, and the cooling. And there we have the battery systems that permits to run the base station by itself for at least 2 hours. This is 2 hours of flexible capacity that can be really useful for the DSO. As you can see here, Vodafone has been installing different demand response technologies at the moment in many base stations. As I said, one base station, it equals 5 kilowatts, more or less. But what would imagine if we aggregate several base stations? In this case, we are aggregating around 20 base stations with a capacity of around 100 kilowatts. This is a really big capacity for one single power line, but imagine if we can extrapolate this to many base stations in the whole city. You can see here the real-time monitoring system that Vodafone has implemented in these base stations. And now I will give you the big overview of the SmartNet project. What is the main motivation of the SmartNet project? To prove in the real field the feasibility of the shared balancing responsibility model that Carlos was explaining to us in 3 types of layers: at the physical network layer, at the market layer, and in the ICT layer. These 3 types of layers are really important for us. And which are the goals that we need to achieve here? Basically, we need to achieve 3 types of goals. First of all is to validate the TSO-DSO interactions. Second goal is to create balancing at the TSO level. And the third goal is to do congestion management at the DSO level. By what? By doing flexibility aggregation of these base stations and to use demand response programs over these base stations. Here we have the architecture, the coordination schemes for the shared balancing responsibility model. On the left side, we have the TSO, then we have the DSO and the CMPs. In the literature of SmartNet, CMPs are commercial market party, which means aggregators. Okay, and as you can see here, in the left side, the TSO is opening a market. This circle means that it's opening a market for ancillary services for generators that are connected at the transport system. And then the DSO is opening another market, this yellow circle, which is local market operator for resources connected at the distribution level. And this line, it's really important here, is the schedule profile. The schedule profile means that the TSO transfers the responsibility of balancing to the DSO. So we become the system operator at the DSO level. It is really important for you to understand this concept because this is what we are trying to achieve here. So we have 2 different markets: ancillary service market for the TSO and local market for resources connected at the DSO. And then we will try to prove these 2 concepts. Balancing in the interconnection point by respecting the schedule profile on behalf of the TSO, so we are responsible of this. And then we will use these things for our own purposes, like congestion management, to avoid congestions in the distribution grid by using the flexibilities of all these base stations. And now, let me give you a little introduction of the roles that we are playing here in the project, because we are playing here Endesa, we are playing one, an aggregator, Vodafone, and Tecnalia, we are, all of us working in this pilot. So, Endesa has different roles. The first role is the transmission system operator. Yes, we are not a transport system operator, but unfortunately, in the project, there is not Red Eléctrica Española, so we have to simulate the the balancing at the interconnection level, simulate. At the same time, we have to develop the interaction between TSOs and the DSOs. Then the second role that we are having is the DSO. It is our natural role. And we are doing congestion market services for ourselves, for our own network. The third role that we're playing here is the CMP, the commercial market party, which is the aggregator. Why are we playing as an aggregator? We are playing as a virtual aggregator in order to stress on purpose the network. Why are we doing this? 100 kilowatts of storage capacity is not enough to stress our networks. It's not too much capacity. So we have to invent, we have to simulate and emulate, for instance, solar PV houses, more base stations, or vehicle-to-grid, for instance. And then we are playing another role, which is the role of a market operator. This is the market operator that we are opening in a simulated way, and we are having here in this market operator all the technical constraints and the economical constraints that I will explain you later on. But of course, as a neutral entity, we see this market operator that we envision that the role of this market operator should be maybe in another agent, not in Endesa, but in the project we are simulating the market operator. Then we have one with David that is playing the role of aggregator, managing the portfolio of Vodafone as a distributor, energy resource owner, and at the same time, he is the provider of the connectivity services and demand response technologies. And Tecnalia, at the end, he is the consultant of the whole pilot. This is the pilot in Barcelona. As I said before, we have three main objectives: congestion management at the DSO level, power frequency regulation and balancing by respecting the exchange program at the DSO interconnection, and then we have to do demand response aggregation by using the storage flexibility of the base stations. And this is how it looks a little bit, the interactions between all the agents. We have a lot of transactions here, a lot of communication protocols. As you can see here on the left side, we have the TSO. The DSO opens a local market and requests for flexibility in the networks that is more congested. So we can solve this situation with the help of different aggregators. In this case, we have one real aggregator, which is one who is having these base stations, but we are also running these virtual flexibility aggregators of PV wind plants, smart houses, and so on. And one important thing is that from the DSO side, we have the smart meters. So at the same time that all these transactions are running, we can have the observability from the DSO that the flexibility has been activated. It is really important for us to see that, yeah, in fact, it has been activated something somewhere, a load or a generation. No matter that the aggregator and the DER owner have their own conversations and their own billing processes. This doesn't matter, but we have to have observability from the DSO. It is really important. And what does it has, this local market operator? We are playing this market operator role by creating a market clearing algorithm that at the end is an OPF, an optimal power flow. This OPF solved in the same optimization model both technical and market-related aspects of the balancing and the congestion. In other words, technical constraints and bit prices are combined in the same optimization problem. And at the end of the day, we want to optimize one economical outcome, which is maximizing social welfare. What is inside of this LMO, of these local market functionalities? We have two different parts. One is the technical constraints, which facilitates the congestion issues from the DSO. The other functionality is the balancing at the TSO-DSO interconnection, and then we have the economical constraints. This LMO is also running the market clearing. We are receiving the bits of the aggregators and also the baselines of the aggregators, so we know in advance what are they going to consume in the future. So this module, this local market aggregator, activates the market clearing, performs the market clearing. And then when it's everything the market clearing is performed, it broadcasts the results, the market results, to all participants, so DSOs, aggregators, and so on, in order to activate the flexibility. This is how it looks. A software tool that we are using here in Endesa that we are performing, we are creating. This is a software tool that we will have here in the DSO, and we will be able to run the three types of agents. We will be running as a DSO, we will be running as a market operator, or we can be run this software tool as an aggregator. And as you can see here in the yellow line, we have the schedule profile that I told you before. And this schedule profile, we need to agree with the TSO in the day-ahead market. And during the intraday, in the activation stage, we need to see how we use this flexibility in order to match the schedule profile. This is really important for us. This is what all the aspects and all the controls that will have this software tool that we are creating for the DSO. We have balancing, flexibility, time plots. We have market prices, market results, and one really nice feature, which is the network status. We will be able to see the network of the city, of these base stations that are feeding these base stations, and we will see if we have a congestion located in one of these networks, in one of these power lines, we will run a market of 5 minutes to 5 minutes, 15 minutes of activation to run the flexibility and decongest and avoid the congestion in our network. So this software tool that we are creating here is really nice and really important for us. What we have been doing so far during this year, we have been writing a specification document that of around 40 pages, describing the roles of all the agents, defining the Vodafone's constraints, the Endesa's constraints, a lot of definitions. At the same time, we have selected 6 primary substations in the city of Barcelona, 6, that are feeding these 20 base stations of Vodafone. So we had to identify the base stations, we had to see the observability of these smart meters are working on those base stations, and we have been installing all these demand response technologies in these base stations. We have been also doing a technical report that is describing all the communication protocols between agents, and we have delivered and designed this software tool that I presented you before. And what do we need to do right now? We need to test. We need to start testing. And when are we going to start? We're going to start actually in a couple of weeks, more or less. In August 2017, we will run this pilot in a real environment, and we will have it run and deployed for 1 year. We will be studying the processes and all the agents and all the communications between all the participants for 1 year. After this test bed of 1 year, we will write a report about all the issues that we will find. And with this report, we could do the cost-benefit analysis that Carlos was mentioning before. The cost-benefit analysis that will put in balance grid expansion versus flexibility activations. And we feel very sure that probably it will be flexibility activation rather than grid expansion, of course. Once we have the results of the cost-benefit analysis, we will check very well the regulatory frameworks that we have in Europe. Actually, we have been doing this for the last year, but the most important is that with these results, we will propose some policy recommendation to regulators in order to be able to change the regulation that we have actually in Spain and activate this type of flexibility. And this is my last thought. What will happen after the SmartNet? I told you that we are working over 6 primary substations, over 20 base stations of Vodafone, so the scope is very limited. But if the outcomes are positive, if the results are positive, one of the next following steps could be to simulate this same project considering a higher number of points of interconnection. So this means covering larger urban areas. This means covering, for example, a whole region of Aragon, a whole region of Catalonia, or a whole region of Balear. Because at the end of the day, what we want to be is the system operator for the distribution resources connected at the distribution grid. This is what we want to achieve in the future. So thank you very much for your attention.